In this video, we're going to look at some examples regarding loans, savings, and annuities, and how we can solve different kinds of problems. So let's look at an example that we have here. A person deposits $500 into a savings account. The bank's interest rate is 5% compounding annually. How much money can be withdrawn after 3 years? So this is a simple problem of a where we're given a present value of $500. We are given an interest rate at 5% compounding annually per year, and we're given the time period after which we have to withdraw our amount, which in this case is 3 years. And we have to find the future value at year 3. Okay. And just to give you a cash flow representation of this problem, year 0, year 1, year 2, and year 3. At year 0, $500 have been deposited. So that's going to be, from your perspective, since you're losing money by giving it to the bank, that's going to be a negative cash flow. And after 3 years, you're going to withdraw that money. Now, once you withdraw that money comes into your pocket, hence that's going to be a positive cash flow. All right. So we covered the simple formula that relates the future value to the present value. F equals P times 1 plus I raised to power n. We know P, we know I, we know n. So this is a simple case of plug and chug. And this, let's pull out the calculator and see what that comes out to. 500 present value times 1.05, and that will be raised to 3 years. Okay, so after 3 years, the amount that we can withdraw is $578.8. And if you want to round that to the nearest dollar, that's going to be 579. Okay, now I want you to understand that $579 at year 3 has the same value as what $500 amount has today. All right, going back to our discussion earlier, that money today is gonna be worth more than money tomorrow. So in order to get the same value that you get from $500 today, you're gonna need roughly $579 after 3 years, and that is gonna amount to the same value. Okay, now let's look at another problem. Let's say a bank gives out loans at an annual compound interest rate of 5%. David takes a loan of $2,500 and he wants to make three equal payments. How much would he be paying in each installment? Would he pay in each installment? All right. So our present value, the loan that we're going to take right now, today, $2,500. The interest rate given by the bank is 5% annual. And David wishes to make three equivalent payments. So at year zero, the money has been taken from the bank. So from David's perspective, that's going to be a positive cash flow. Year one, year two, and year three. Since David is going to be making three payments, and let me just specify he wants to make these three equal payments each consecutive year. Okay, so that means on year one there is going to be a payment, on year two there's going to be a payment, and on year three there's going to be a payment. Notice how each of these cash flows has the same length. That means that they have the same cash amount. As we have discussed earlier, the same cash amount does not equal the same value across different time periods. So let's say, if for example, if this amount is A, this amount is also A, this amount is also A, the cash amount is equal. This is a certain number of dollars, this is a certain number of dollars, so is this, but they don't have the same value, and that is the key concept that we have to understand. So in order for the bank has to balance this positive cash flow with these negative cash flows. So the $2,500 amount has to be equivalent. In order to make that possible, you have to take these cash flows, you have to take their value at year zero. Okay, so in order to take the value of cash flow A at year zero is going to be A times 1 plus I divided by 1, since you're taking it back 1 year. And for A the next year is going to be 1 plus I raised to power negative 2, since you have to take it back 2 years. And the third one is going to be plus I raised to power negative 3. These terms right here, they're known as the discount factor. Okay, what that means is they are in essence a correction for the effect of time on the value of money. So by multiplying A with 1 plus I raised to power negative 1, you are getting the value that this money would have at year 0. Same is the case with A here. You're getting the value that this cash flow is gonna have at year 0. All right. So we know, since we know I, the equation becomes 2500 equals A times 1 plus I 1.005 105 105 to minus 2 1.05 to minus 3. Okay, and in order to, you'll find Excel very helpful in such problems. Here we only have a total of 4 cash flows, but you're going to be dealing with tens, 20, maybe more than that. Like, since chemical plants have a plant life of around 15 to 20 years, so you're going to be dealing with a bigger number of cash flows. So I'm going to take this moment to demonstrate the solution in Excel. Okay, so we have our, zoom in for you, present value 2500, and our interest rate is 0.05. Okay, now I'm gonna represent my cash flows. I have my years in this column, and it goes from year 0, 1, 2, and 3. Okay, and in the next column I'm gonna have the respective cash flow. Oops. Okay, there we go. At year 0 there is a positive cash flow of 2500, and let me just format this in using the accounting formatting. Okay, and let's say we make an initial guess for the payment, and let's say it's around whatever is 2500 by 3. Let's take that as our initial guess. Okay, so, and since these are gonna be payments, they're gonna show up as negative cash flows, and I want to make this the same formatting. Okay, hold up, I need to make this the absolute reference. Yes, this cell needs to be okay. All right, and then I'll just drag this down. In the next column I'm gonna have discounted cash flows, DCF. Actually, just to be more explicit, I'm gonna have the discount factor in between. Oops, discount factor. Okay, there we go. Now the discount factor is just 1 plus the interest rate and raised to the power negative of the respective year. So for year 0, the discount factor is just gonna be 1, because $2,500 today are worth $2,500 today. And then we just copy this down. And as the year progresses, the discount factor becomes smaller and smaller. This shows that money loses its value as time goes on. And to discount each cash flow, you just have to multiply the cash flow by the discount factor. In order for now, the bank needs to balance the negative with the positive. So the sum of the cash flows has to be 0. Okay, so I have a sum here. And this sum is also given this total amount is called net present worth, since we're taking the value of all the cash flows at year zero. Now our objective is to make this NPW zero by varying the payments that we're gonna make. Okay, and for that I'm gonna be using solver, and you can use goalseek if you like. Okay, my objective cell, value of 0, by changing cell A, and I don't have any constraints. Okay, so $918.02, that's the payment David will have to make each year. Notice how I've only used one formula. F equals P times 1 plus I raised to power n. And if you rearrange this to in the form P equals F raised to power 1 plus I times negative n, there you get the discount factor. Okay. There are other formulas. For example, this right here, this is a uniform series of cash flow payments, and there are formulas that allow you to compute this number A right here without doing detailed computations. But if you have a good command on Excel, you'll be able to get through any problem this using this method that I've showed here. And I hope this was helpful, and we'll be back with more time value problems.